So let's start. Hi everyone. My name is Simonas, and today I'm going to tell you a story, an enterprise story, how we, with my colleagues, have participated in a transformation of an organization which is, as you know, in Vilnius, Lithuania. It's called Danske Bank Group IT Lithuania. And this story actually reaches out back to year 2015, actually, when I joined the organization. And I will tell you a story, what I found there, and what steps did we take to actually end up in an organization that has been to which we have transformed it today. I'm really excited to be here, and before I kick off my slides, I just want to dedicate this slide to my workplace, which is called DGITL, and the building that you can see on the left-hand side is called a unique building, where we have not only these spaces where we work and rest and do all the nice things, but we also have things like fully blown data center for testing IT stuff from server storage to whatever. So this is our kind of second home, and I'm sure that you've seen this building. Now, after I tell you the story, the next thing in the agenda is going to be a demo on actual production environment. So it's going to be fun. I hope it works fine, but it usually doesn't. So it's going to be like with some glitches, so be prepared for that. Danske Bank Group IT Lithuania can be defined with these few numbers. Today we have over 1,000 employees, and these employees are coming from more than 350 companies. So we have like quite a diverse community and people. We have 13 different countries, and we have a very healthy split between development and the CTO, or as we call it, the ops organization. So devs and ops are like 50-50. Yeah, we should have probably have more females in the house, but it's a healthy number. When I was a student in my class, out of 35 students, there were only 6, maybe, yeah, there were 6 females. So this is a healthier number than it was at my university, which and coming back to the university degree, 86 have university degrees, and the average age is 30, managers 34, I'm now 36, so I'm kind of like out of that number. So today I'm going to tell you a story which, like I just told you, reaches out back to the year 2014. And this picture is symbolic a little bit. Maybe you could interpret this picture somehow from the context of this presentation. Yeah, Windows and Big Bang, very good. So we don't challenge what was before the Big Bang in 2014, because we think that there's like it's a point in time. We think that it was that Danske Bank or Danske Bank Group IT was a Windows shop. And what we found there in 2015 was actually just 20 Linux servers on the inventory. It's a funny number, I would say. So when I joined in the year 2015, the first thing that I was tasked with is to create a build, create a Linux build, and I didn't know what that means actually. What is a build? So end of the day, I found out that the build has like, okay, you take a vanilla Red Hat or whatever Linux and put stuff which is Danske Bank specific on top, and then you make it available to the developers to use. So okay, I said it's going to be a fun thing. So we started with Red Hat Enterprise Linux version 6, and we took Chef for configuration management, and it was all more or less decided by our team, which was a newly established team in Vilnius, Lithuania. And well, we thought it's going to be all right for some time. What the developers need actually, they probably need Linux. They got enough Windows already, right? So and then we launched a some sort of like a private cloud, which we call version 0, actually, not even 0.1. So we took the Windows build, we took the Linux build, and then we ended up with having some sort of VMware VRO, VRA product that allowed users to click through and get a virtual machine running. Now, all of you now are a little bit confused. So how does this tie to the topic of my presentation? So the question is, is the VM back in year 2015, was the VM actually what the developer needed? Was it the right thing to do? Did we ask, do they need VMs, or maybe they need something else? So then in a couple of months, we started to ask questions like, okay, let's turn on common sense. What do the developers actually need on the platform, on the private cloud? And then some guy from the back of the auditorium one day during an all-hands call said, we might use a bit of messaging, you know, maybe you could consider running some sort of like a RabbitMQ or on top of that. Then we said, hey, it's a great idea, let's run RabbitMQ. So we did first RabbitMQ steps on top of that. In the end of the day, we did the first move. We actually asked the developers what they need. So the first response was, okay, we need some messaging, okay? Obviously, Microsoft product portfolio has had databases on it, so they had databases to some extent, I don't know. But in any event, so that was the year 2015, we made baby steps in the organization, how to transform it to an extent where people can work, actually deliver stuff. Okay, going forward, year 2016. So obviously we had to upgrade to Red Hat Enterprise Linux, and we actually moved from that vRealized VMware product, which we barely could develop. We moved the private cloud to ServiceNow, which is a powerful tool. It's a bit over-engineered, I would say, but at that point in time, we had a very good establishment of ServiceNow in the organization, and we thought it's going to be a good idea to move the private cloud from something that is really monolithic to a platform where you can change stuff, add stuff, you know. So when we moved the private cloud to ServiceNow, we were able to actually give developers stuff that well, we gave more new offers in the private cloud. So initially we started with, again, making an all-hands call, and then from the back of the auditorium, somebody raised a hand. Hey, could you do an elk stack for us, please? They say, hey, we can do it, no problem. So we ended up having an elk stack on the platform. So that was a message, because those things like RabbitMQ or Elastic Stack, they really kind of like lifted off really fast. So we thought, okay, maybe it's not the VMs that they actually need. They might need something else on the top of the IaaS, the classical platform. Okay, so the next iteration, somebody to whom I chatted before in this conference came up with an idea of having a PaaS platform instead on top of the IaaS as we know it, and the idea of having an OpenShift enterprise came at the end of the year 2016, and the overall idea was like, okay, we do have Red Hat in the house as a vendor. It's a trustworthy vendor. It's based on open source. All the products are actually open source. So let's make it another deal with Red Hat and get a PaaS into the house. And this is where actually the Kubernetes story has started, because as you may know, OpenShift is a product which is based on the Kubernetes framework. Now, so the year 2017. So in this year, on the IaaS part, so on those servers that we built, the team was like 8 people at that time. On those servers that we provided on the platform, we observed some of the e-banking stuff moving to our Linux instances. So we thought, okay, we're getting serious business now. If you just turn off some server, it's going to be a mess somewhere in Denmark if you click a button in Vilnius. So we upgraded and we see the Rails 6. So we had to also lifecycle stuff and do other things for the IaaS platform. But end of the day, in this year, we've actually managed to release OpenShift version 3.4 into production so that the developers could at least start using this platform. So we started with just a handful of projects on OpenShift, and obviously we had to, well, it's I'm simplifying, but we had an all-hands call, and then somebody said, like, could you do a CI/CD for us? So we came up with Jenkins, and so the message is that we still kept developing on the IaaS platform, but we went live with OpenShift 3.4 at that time, which had a lot of stuff in place already. So this is where the story actually started to actually materialize. Year 2018, so that was an interesting year. So we thought it's okay to have a private cloud on some proprietary ServiceNow platform. That was okay for some time, but then we suddenly ditched all of that. Today our private cloud version 2 runs completely on in-house written software. It implements Open Service Broker API. It has Terraform provider. It's fully automated, and it doesn't rely. It has zero vendor footprint. It's all in-house developed. It's Python with Django REST API, and it's purely it's inner source, so it doesn't have any binaries or something. So we'll come to that in a moment. And the OpenShift actually lifted off really well. And in year 2018, we removed. We were actually the initial setup of OpenShift was in the LAN, in the safe area of Danske Bank, where all the workplaces live. This is completely isolated from the outside world. So people thought, oh, if you unleash this to the, if you let the customers face the system, it's probably buggy, it's probably insecure, blah blah. But then it launched in DMZ, and DMZ, the place where we actually expose services to our customers. And I will come to the slide where it talks what actual services we expose to the customers. We also reduced its complexity and removed the virtualization layer because it became quite unnecessary. So we optimized and went bare metal, and we were just one of the few companies that actually, at that scale, I will come to the scale in a moment, at that scale we went bare metal with Kubernetes. And obviously there were major upgrades running in the background all the time, so we had the commitment to, okay, we're a bank, so we probably can be 5 versions behind the latest. No, we're only 1 version behind the latest. Sunny day scenario, rainy day scenario, 2 versions behind the latest version. So there were constant upgrades, there were constant chaos. So we were our own chaos monkeys, actually test the infrastructure, reboot the servers, see if the applications can survive and do different things to make the platform more resilient to failures. So in the end of the day, what is OpenShift? So you might not be familiar with it, and with the exception of my Danske Bank colleagues, would you please raise your hands who was doing some hands-on on OpenShift as a product, or on an open source version of it, the OKD? Okay, okay, a good audience. So OpenShift is actually, okay, by the way, Kubernetes, just raise your hand. All right, okay. So OpenShift is Kubernetes at the bottom. It runs on Docker, or it can run on Kubernetes runtime. It runs on physical, virtual, private, public, whatever. This is marketing. On that framework, what is the difference between Kubernetes and OpenShift? The main difference is that it's like if you compare Linux as an operating system to FreeBSD. So the FreeBSD is the actual operating system, and Windows is the fully blown operating system, whereas Linux is the kernel. So Linux, Kubernetes, FreeBSD, or Windows is OpenShift. It's a full-blown system where you deploy the framework, the Kubernetes framework, together with logging, together with metrics, together with dashboards, together with builds. So you have to focus only on writing the code, and which makes the system really exciting to use, because you give the system your code and it just pops up a working application. So it's all about self-service. I guess that's one of the things why it took off so good. And everybody loved the Kubernetes API and the OpenShift extension of that API, so we didn't have to do a lot of self-service around it in the end of the day. And yeah, I think that there is more just a product. It's really it made a bit of culture change in the organization by just having all this inside. This is our internal promotion. Why developers use OpenShift is if you want to do a simple .NET Core application on some server in an enterprise organization, it would take you at least 2 days, if not more. If you want to run, take your servers, install the runtime, install the active-passive setup if required, install load balancers, virtual IP addresses, routing, TLS, whatever. I hope we will be able to squeeze the PaaS version of it into this presentation. I guess it's going to take less than 15 minutes. So it takes up developers to speed. And the difference between Kubernetes, the essential difference is that you can deploy to Kubernetes, but you have to use Helm, you have to do S2I or something else. In OpenShift, the S2I is baked in, so you don't have to worry about building. It just takes your code and creates a build container and then creates a deploy container out of it. Why ops use it? We have been struggling with the chef configuration management to define where actually the developer experience ends and where the infrastructure, the ops experience begins. So there is a huge gray line of dependency hell in that configuration management on the IaaS platform. So if you want to run some chef cookbook and give a person an opportunity to run his or her own cookbooks on the server, which might just deploy the same piece of .NET code, or in this example, RabbitMQ test is an actual example. In the end of the day, you'll get this map of dependencies, and you never know who is responsible for what. Oh, log rotate. So who's responsible for the server logs? Is that the developer, or is that the server operator? So we don't like DevOps in Danske Bank. Well, we do like, but it's a message that tells you that you have to know the whole stack. So, but there are teams that are running the other part of the stack, and then you collide. So that's why we don't like the term, because we have to have it. We like to have it segregated. And why we love OpenShift is that it defines a clear line: who is the dev and who's the ops. And if you ask me what's exactly that line, I would tell you it's containers. It's the pods. And for those who are using Kubernetes, you probably know that already. Okay, so what do we get out of OpenShift? So obviously we get programming languages, we get the runtimes. So once we get the runtimes, we might consider having some middleware or database layer attached to it. This is an example what is by default available to every person who uses OpenShift in our setup. There is more to that. If you buy additional subscriptions from Red Hat, you can have JBoss, you can have 3-fork, a lot of middleware things, but I'm not going to extend on that. It's very important that OpenShift handles CI/CD transparently, meaning that you need to only drop the Jenkins file definition to it, and it will take care of setting up a Jenkins deployment, feeding that configuration into the Jenkins instance, and do other stuff like creating ingress routes, so on and so forth. And this is why some people just ask us the questions, not how to run Jenkins, but do you have a unified pattern for like the CI/CD configuration? Because we're thinking at that level. We don't think about like how much CPU Jenkins consumes, or what is that, like maybe there is a crash, maybe there is a slave that's not spinning. No, we don't talk about that. We just talk on the level of Jenkins file on the purely infrastructure as code layer. And this is a bit outdated slide, which I almost intentionally left as is due to a number of reasons. One of them, my Jupyter Hub crashing before presenting this, adding this slide. But it was you can imagine, 2017 March, we took off with just a handful of like, how many users? 50 projects. And then, 10 projects. I lost it. Okay, anyway, what I want to convey with this slide is that this line shows the total number of users and projects, these two lines. Inside in the system, it's now more than 1,000 already, both in terms of projects and users. In Danske Bank, we have, in the global group, we have more than 2,500 developers that do develop stuff on OpenShift, out of which more than 1,000 has been onboarded to OpenShift, and it reached 1,000 somewhere end of 2018. So this was the transformation. These bars show how many people onboard to the system and how many projects onboard to the system on a monthly basis. So initially we had this explosion, then there was like, oh, OpenShift sucks, maybe it doesn't work, like it doesn't do my expectations. But then again we had this consistent increase in growth on a monthly basis because the word got spread, and eventually people started to copy best practices. People started to establish forums, establish knowledge sharing sessions around OpenShift, and obviously around the components in it. And end of the day, we have got the buy-in from more than half of the organization as it is today in end of 2019. So we've been capped by some technical limitations, so we had to spin on more clusters, and so this is one cluster's perspective, the first cluster perspective, and so I did not update the slide because of a number of other reasons. Right, so coming to the end of the slides and maybe doing a demo in a moment, I would like to reflect a little bit about some business units and some products that are running on OpenShift today. And today we have a couple of more that I also did not include in the slide because of their just doing initial POCs. We have June, which is a investment portal by Danske Bank. We have a online meeting booking, so if you want to book a meeting with a Danske Bank representative, you use an application which runs there. We have anti-money laundering, also doing a lot of reporting on OpenShift, because you can do it like a function as a service. You can spin up, just give it a Python script and it runs it for you. Right, so we have some sort of like a lot of mobile apps running on OpenShift. We have a district financial dashboard also. Its front end being run on OpenShift. In addition to that, car leasing websites and many more smaller maybe projects or equal projects running on OpenShift to some extent, to full extent. So it depends on the choice of the architecture. Now, can OpenShift do all that alone? Probably not. You need to have good tools to actually make it work. As an example, you might be aware of Kubernetes ingress. That has been a pain because if you're not an administrator of a Kubernetes cluster, you might just want to get, I don't know, a dedicated ingress IP plus DNS name plus IP address management plus whatever. OpenShift doesn't give you that. Kubernetes doesn't give you that. You have to install like a different set of like, okay, I need a CNI plugin, I need Flannel, I need probably a router, Nginx router. It doesn't support TCP, UDP, whatever. It just supports HTTP, HTTPS. Avi Networks is the partner here, which deploys Avi Vantage router, and it makes things happen really well. It has been a journey that we had with Avi Networks. So there are like I'll just boil it down to a couple of, to an example where a big company asks for a small startup to do business together. So yeah, but they did really well as a small company, and now they grew to an extent where VMware bought them. So I'll come to that later again in the demo. Artifactories for being disconnected safely from the internet and not having the latest NPM vulnerabilities in the house. So Bitbucket obviously as a Git together with the whole Atlassian stack, or you might just want to go do it like what was before Big Bang. We had Visual Studio, Team Foundation, whatever. So there are other tools, but these are one of the critical things that we're hooked to, and these make all the things complete. Now, so So now it's the demo time, and as promised, I will show you a quick demo how to go from code to an actual deployment. If you haven't seen that, you might be interested in the details. So this is the actual production environment where I'm in. I hope it still works and I wasn't disconnected. Last time I did this demo, I was just cut off at this stage. So, okay, let's consider this. This is a demo application. You joined Danske Bank Group IT Lithuania, and on your first day you got your laptop and you coded in some sort of like a demo app in Node.js. And you put it on some project in Bitbucket. Okay. Now what do we do? If you want to deploy this the classical way, you would probably spin up a Docker instance like I have here on my laptop and maybe push it somewhere. You don't know, you're on your first or second day of work, and then you have to imagine you would need to have to do that on your first day. So instead of just worrying where to put it, you ask access to OpenShift, and then you get the demo project. Well, initially every person who gets first-hand access to OpenShift gets access to 2 demo projects that are wiped out. There are 2 because we have to demonstrate CI/CD pipelines. So therefore, we have 2 projects where you build on one and deploy to another. So, and then you go add to project. And then you might just want to browse the catalog, which is full of stuff. Like you can do Dancer, you can do GBoss, BPM Suite, whatever. Let's go to languages. Let's pick Node.js. Actually, if you use command line, which I'm a fan of, you would never have to do that. You can do it in a single CLI command, but I'll just put it here. Build stuff. I'll give it a name. Okay, and you put a Git repository. Technically, that's it. Now, to make it run, to make it build better, I will add one. Instead of injecting our SSL chain, I will just put this variable here. So now 2 things that I've done as a general things, name and repository, and some small environment variable. And I'm going to create the app. So build stuff has been created. Okay, what do we do now? We go to project overview, and where is the build stuff thing? Okay. Now this is the build stuff application. So what is actually happening in the background? Can you tell me? What is going on right now? What building? Yeah. So you probably know npm install and all that stuff. So basically, you can do it 2 ways. You can define what sort of application you want to deploy, or you can let OpenShift guess and say, oh, there is a package JSON file on the top of the repository. It must be a Node.js application. Oh, there is a requirements TXT file. It must be a Python application. Or there is a NuGet config file. Okay, that's .NET Core. What if both? So it will probably just pick first. But then you can always fall back and specify if both. So maybe, well, just alphabetical order. I don't know. Good question. I never tried. Separate repos in our case, but I don't know. Maybe I'll try. I'll just try. I never thought of that. It's so simple. This magic. We'll just have like, there is a Unix utility called file. So it also guesses what sort of file is that. So okay, you might be guessing whether it's like a PDF or a zip file or whatever based on conditions. So maybe it's doing that sort of a guess. In any event, now what's going on? Now the build is complete. Now we have to package the build image. We prune the development dependencies. We only leave the runtime. Well, obviously, if it's a .NET Core or any other compiled language, you compile. And then you push the image. So you strip the image from any unnecessary dependencies. And what happens? Okay, 1, 2, 3, it will go to 100%. There is already a deployment set which waits and listens for the OpenShift image stream. And it waits until an image becomes available. And when the image becomes available, it triggers a deployment, which happens here. And we have one healthy pod already with your runtime packaged and available on a Kubernetes as a pod, as a replica set. You might scale up, scale down. This is a replication controller thing that you scale up to 2, scale up to 3. So this is the OpenShift basics. And these basics are good, but not good enough for a developer who wants to see the code in action. Now, how to see the code in action is actually, well, what do we have here? A fully working URL, which says something build stuff demo project, pass dblan, danskenet.net. Looks like a URL I will probably have to click. Now, I click it. Oops, doesn't work. Let's figure it out. Why doesn't work? Port 880. We add port 880. This is a demo application. So it took me like, I don't know, 4 minutes to deploy from a code to a fully working URL with there are also options available that make your application automatically secure by providing an HTTPS certificate. Now what you can do, you can scale your pods, you can change something in your code, rebuild, redeploy, and do things like, I don't know, even things like rolling deployment. They happen just, I haven't even asked for this, but it happens. So it's probably now spinning up a new pod. Yeah, it's becoming ready, warming up. As soon as this becomes blue, the Kubernetes replication controller will start killing off those 2 old pods, because these runs old version of my app, and here I have deployed a new version. In the meantime, the application is still working. So it will release a new version whenever the old pods are gone. Okay, they're gone. So it's probably a new version running already. And at the end of the day, you can do blue-green deployments. You can change your service configuration here, like, what is that, build stuff. I need to probably change the port to 80 or enable SSL for that. And you have a lot of things here under deployments. So there is a deployment configuration that has been created. So it defines how you deploy your application. Under builds, you have your build configuration, which says, take this source repository, take it from a master branch, use a builder image OpenShift/Node.js 10, and send it to this image stream. Whenever this image stream has been updated, then you just simply roll out a new version. You can do triggers, you can do GitHub webhook URLs here, and set environment variables, and have a healthy history of things happening on that project. In addition to that, you can deploy the usual stuff, databases, middleware, like I showed you before. And there is a bit of storage here as well, so if you want to have a non-ephemeral storage, so in the case of Kubernetes, you would have to use persistent local volumes. That would end up in creating a local volume on the machine where you are. So if you move your pod to another machine, because obviously you want the replication controller to work, if you move it elsewhere, then you lose the persistent local volume. So in the end of the day, you would like to create a storage, and I say, I want to have a build stuff with 5 gigabytes. Well, there is a storage solution for that. It's not there in Kubernetes, but it's natively available as, it's called Kubernetes native container native storage based on GlusterFS. And now I have a 5 gigs volume with a read write once setting, which I can attach and save my, I don't know, Jenkins settings, whatever. So that is pretty much what I wanted to convey today, and I really hoped that you liked what you saw, because thousands of people love this. Not necessarily the enterprise version, but the OKD open source version. You can run it yourself. If you have Docker on your laptop, just pull the OC client from the GitHub repository, and you do OC cluster up, and you get a fully working cluster with dashboards and everything. I tried to install Kubernetes overnight a couple of days back. kubeadm doesn't work. Minikube, suddenly node external IP is gone. I don't know why. Minikube, something missing. Nginx runs fine, but doesn't see the external node IP, doesn't work. And then you need the dashboard, you need this, you need that. So it's like you buy a whole kitchen from IKEA and have to do it yourself. So then this, you buy this, or you just take it for free, basically, and have everything as a product. Okay, and last but not the least, questions. Okay, Kęstutis is asking, what are the risks you see to use OpenShift products after IBM bought Red Hat? And this is a question which I'm getting too often. And I would say, I would rephrase this question the way some person asked me in the group IT. Said, how would you manage the risk of licensing and whatever if the licenses would be more expensive after the IBM acquired your company? Then I came to the person and said, you know how we manage the risk? We stop paying. That's it. It's open source. So you can always fall back to open source version. You're not happy with OpenShift Enterprise? Fall back to OKD. It's exactly on the same version. It's exactly the same components inside. Technically, the images are built differently, but it's like CentOS and Red Hat. So you just stop paying and bye-bye. How would we manage secrets? Next question by Anonymous is we manage secrets in OpenShift secrets. They are stored in OpenShift secrets, and where is that? Resources, config maps, secrets. We have a bunch of secrets. You can store certificates, SSL keys, SSH keys, whatever. These are for secrets. If every developer can do this, then when the servers get overloaded with all sorts of stuff constantly running. There's one question I'll take together with the next one. How do we take different environments and how do we move between dev, UAT, and prod? Okay, first of all, how the servers don't get overloaded is that we have resources, quota. And then we have a very nice definition of what is a request and limit. So request is a hard reservation. I'm getting half of the CPU as hard reservation for my project. I don't need more. But if I want to burst, I can go up to 4 cores. And the same with memory, but memory is equal. You don't usually burst with memory, especially when you have a static GDKs, GRAs running. So if you run a Java runtime, you just pass some parameter, how much heap, how much memory you want to assign to that process. So memory is usually static. Now, and actually I haven't shown this, how we manage different environments, so let's come back to that. So we have this builds, pipelines. Oh, it failed. Anyway, so we have 3 minutes, maybe it will warm up and start. So this is how we manage different environments. So this is now experiencing a build on a development environment. And once this kicks in, this is going to deploy on the development environment and validate the deployment on the development environment. And using the same credentials, it will hook up to another namespace or a project in OpenShift, which is called demo project test. And then we'll tag the Docker image from dev to test. And then it will automatically trigger a deployment on the test environment. And then what is left for this pipeline is actually to just verify the other project. Did we land it on test or not? And then that's pretty much it. If you look closer on the definition of the pipeline while it runs, it has a Jenkins file. So you don't have to do much else just to drop a Jenkins file here. Just like edit YAML, store it in your Git repository, and this is your Jenkins file. You say, I want to build on this project. I want to verify the deployment on this project. I want to promote it to test environment, so I do the Docker tag thing. And the end of the day, I just verify the deployment, and that is pretty much it. You can do very complex things with this, and I'm not ready to show you the complicated pipelines that we have in the house, but we have like pipelines with 20 steps, 30 steps, up to production. So what I want to show you is actually that there is a Jenkins instance running silently in this project. And if you don't do this yourself, it automatically appears here. And it's even available over, it's just nobody took care about the certificate, but anyway. So I'm logging in with OpenShift to this, and I'm ending up in a full-blown Jenkins instance, which says like, oh, you're running a demo pipeline here. Oh, let's have a look. Oh, okay, it's building on dev. Cool. Shall we open Blue Ocean? Yeah, maybe. It will take a bit of time to load over this Wi-Fi. It's heavy, by the way. But then, yeah, very simple pipeline. Start, end. It will expand, actually, with other steps once this completes. Okay. It just did, by the way. So that's how you actually promote between UAT. Right, and I guess no more questions. Oh, okay, there is one. How we terraform our secrets manually in OpenShift. So I'll just summarize. You can use OpenShift API to terraform your secrets. We have Terraform available as a provider, and you can switch from terraforming the actual private cloud to terraforming the OpenShift instance directly and put your secrets there. And yeah, release management will probably take another hour to explain how we do release management. So thank you everyone for listening today. That is the end of my demo, and I wish you a happy conference.